Hi everyone, welcome to the Unit 6 practice test virtual key. Hopefully you get some benefit out of this video. Don't forget you can always pause and rewind as you need to. Let's jump right into this by looking at question number 1. Question number 1, the directions say find the value of the variable that will make the polygon a parallelogram. So we know this about parallelograms. We know that if this thing is going to be a parallelogram, that we have opposite sides have to be congruent, and also opposite angles have to be congruent. So this side, labeled 7, is going to be the same as the opposite side, 16 minus h. As well as we know the bottom, 11, will be the same as the top, which is not marked. So if I wanted to know, this is actually 11 as well. It doesn't ask us for that, but we do know that that top piece has to be 11 as well. So let's go ahead and find h. Let's set up our first equation as 7, the left side, is equal to 16 minus h, which is the right side. The left side must equal the right side. Solving this algebraically, I can subtract 16 on both sides. 7 minus 16 is negative 9. That is equal to negative h. And then I can divide or multiply both sides by negative 1. And I get my final answer to be positive 9 equals h. So h is equal to 9. Now to find g, we also need to know not only do we have opposite sides congruent, but we also know that we have opposite angles congruent. So this angle will be congruent to this angle. Right? The top left will be congruent to the bottom right. Top left angle we call g plus 4, and g plus 4 will have to be equal to its opposite angle, which is 65. In order to solve for g, I subtract 4 on both sides. I'm left with g is equal to 65 minus 4, which is 61. So the answer to number 1, finding both variables, h is equal to 9 and g is equal to 61. Looking at number 2. Number 2 is also a parallelogram. It says find the variables that would make this thing a parallelogram. The next two things we need to know about parallelograms. Yes, opposite sides are the same, so the bottom is 45, so the top has to be 45. The right side is 21, so the left side is 21. I know all that. However, my variables are now inside on my diagonals. One of the things that we should know about all parallelograms are that the diagonals bisect each other. So both diagonals will bisect one another. That means 5x and 4x plus 4, those have to be the same. This piece is the same as this piece. So 5x and 4x plus 4 have to be the same because diagonals bisect each other. The word bisect means to cut in half. Solving, I'll subtract 4x on both sides. And that leaves me x equal to 4. Remember, we said diagonals bisect each other. So not only does the left to right diagonal, going from top to bottom, get bisected, but also the bottom one. So 3y and y plus 8 have to be the same. 3y and y plus 8 have to be equal to one another because diagonals bisect each other. Solving, subtract y on both sides. 2y is equal to 8. Divide both sides by 2. And y is equal to 4. X equals 4 and y equals 4. With those values, both of the quadrilaterals and 1 and 2 would be parallelograms. Moving on to number 3. Number 3 says quadrilateral QRST is a rectangle. Find x. So there are a few things we should know about rectangles. The first thing I have to know about rectangles, it is a parallelogram. All of the traits of a parallelogram are traits for rectangles, as well as two very special new traits that go along. The first one, all opposite angles are 90 degrees. So angle Q is 90, angle R is 90, this angle T is 90, and S is 90. Also, the diagonals are congruent in rectangles. The diagonals are congruent. In order to solve this problem, however, I will be using the fact that I have 90-degree angles. As I look down here in the bottom left corner, 4x plus 5 is this small angle. 9x plus 20 is the other angle. And we said that they are perpendicular, so that means if I add these two together, it has to equal 90. That's what perpendicular means 90 degrees. To solve this, combine like terms, 4x and 9x will combine to give me 13x. And then 5 and 20 will combine to give me 25. Still set equal to 90. Subtract 25 on both sides. It means 13x is equal to 65. And then divide both sides by 13. And you may need a calculator here, but x is equal to 5. X is equal to 5. Remember, all rectangles have two new properties that other parallelograms don't enjoy. They have 90-degree angles in the corners, and their diagonals are congruent. Question number 4. It says the following figure is a parallelogram. What does that mean? Well, if it is a parallelogram, the top and bottom are parallel. The left and right are parallel. We know that opposite sides are congruent. We know that opposite angles are congruent. The whole list of 7 or 8 different things that we know about parallelograms is all true. Going on, it says D is a right angle. So D, down here, this is a right angle. It's 90 degrees. Hopefully you remember that one of the traits of parallelograms said if there is one right angle, there are 4 right angles. Which means that as this is a parallelogram, this is more than just a parallelogram. This is a very special parallelogram that we call a rectangle. It is a rectangle. And it is a rectangle because it is a parallelogram that has right angles. One of the traits of rectangles, we said it has 4 90-degree angles. The other trait are that the diagonals are congruent. So this problem tells us BD, the distance from B to D, this diagonal, the whole thing is 4x plus 3. AC, let me change colors. AC, from A all the way over to C, this diagonal is 2x plus 35. So my two diagonals are given, and because it is a rectangle, the diagonals are congruent. So 4x plus 3 will equal 2x plus 35. Solving, I can subtract 3 on both sides. 4x equals 2x plus 32. Subtract 2x. 2x is equal to 32. And divide by 2. And x is equal to 16. X is equal to 16. Moving on. 5, 6, and 7 say classify the quadrilateral. Explain your reasoning, then find the value of x and y. So let's classify. I'm going to classify number 5 first. The classification for number 5, it is a four-sided figure. It means it's a quadrilateral. Opposite sides are congruent? Yes. Not only opposite sides, all the sides are congruent, which means yes, it is a parallelogram, yes, it is a rhombus, but even more, it is all four sides are the same length and 90 degrees in the corners. This is what we call a square. All four sides are the same length and 90 degrees in the corners. Because it is a square, I can set any of the sides equal. Yes, opposite sides are equal, but more importantly, all sides are equal. So I'm going to take the two that have y, 5y plus 1 and 2y plus 4, and I'll set those equal. 5y plus 1 and 2y plus 4 have to be the same distance. They have the little markings. You can see the marks on them. The one mark tells me that it is the same. Subtract 2y. And I'll also subtract 1. I'll double these steps here. 5y minus 2y is 3y. And on the right side, I would have 3. Divide by 3, and I get y to equal 1. In order to find x, in order to find x, I do the same kind of thing. 5x minus 4 and 3x. They will also be the same. 5x minus 4 equals 3x. Add 4. Subtract 3x. 2x is equal to 4. Divide by 2. And x is equal to 2. So y is equal to 1 and x is equal to 2. Question number 6. Question number 6, taking a look at the four-sided figure. Yes, it is four sides. It's quadrilateral. Opposite sides, are they congruent? Yes. So it's a parallelogram. All sides are congruent. Yes. That means it's a rhombus. And is it a square? No, I don't have a 90-degree angle. So this one stops at rhombus. We have a rhombus, a four-sided figure with all four sides the same. All four sides are the same, which means 6y minus 5 and 3y plus 7 can be set equal. 6y minus 5 is equal to 3y plus 7. Solving. Subtract 3y on both sides. Add 5 on both sides. 3y is equal to 7 plus 5 is 12. Divide by 3, and y is equal to 4. Y is equal to 4. In order to find x, I need to know something about the consecutive angles of a parallelogram. And consecutive angles to any parallelogram, whether it's a rhombus, whether it's a square, whether it's a rectangle, whether it's just a regular parallelogram. The consecutive angles of all parallelograms are supplementary, means they add up to 180. So 2x minus 1 and 127 can be added together and set equal to 180. Means 2x plus 126 equals 180. Subtract 126 on both sides. 2x is equal to 54. Divide by 2. And x is equal to 27. X is equal to 27. the last problem, problem number 7. Problem number 7, I first have to classify this. It has 4 sides. It's a quadrilateral. I don't know that opposite sides are congruent. It doesn't tell me that, but it does show me that I have 90-degree angles, which tells me that the top and bottom are parallel, the right and left are parallel. So this is a parallelogram. A parallelogram that has 4 right angles is called a rectangle. And are all the sides the same? I don't know that. So I am stuck with this just being a rectangle. Because this is a rectangle, like all parallelograms, diagonals bisect each other. So 2y and 10 have to be the same. 2y equals 10, divide by 2, and y is equal to 5. That one was pretty easy. The next one's a little tricky. 5x is the angle right here. And 3x plus 18 is this angle down here. And you may be wondering, what is the relationship between these two angles? Well, if you look at the top and bottom as being parallel lines, 2 parallel lines cut by a transversal, those 2 angles are alternate interior angles. And we should remember that alternate interior angles are congruent. 5x is equal to 3x plus 18. Subtract 3x. 2x is equal to 18. Divide by 2. And x is equal to 9. X is equal to 9. Y is equal to 5. That takes us through questions 5, 6, and 7. When we get to question 8, 9, and 10. Question 8, 9, and 10 says find the value of the variables and the trapezoids. Some of these are very special trapezoids. If we look at number 8, number 8 is a very special type of trapezoid because of the marks on the legs. A trapezoid that has 2 congruent legs is called an isosceles trapezoid. An isosceles trapezoid's first major trait is base angles are congruent. So this angle is the same as this angle. Makes x equal to 50. That one's really easy. To find y, I have 2 parallel lines cut by a transversal. And these are same side interior angles. Same side angles are supplementary. So my x, which we said is 50, plus y will equal 180. So y equals 130 degrees. X is 50, y is 130. Number 9. Number 9 is a trapezoid. Top is parallel to the bottom. I do not know that it is an isosceles trapezoid, but I do know this, that the segment that is labeled with X, right in the middle, connects the midpoints of the 2 legs. That means by definition that this is called the median or the mid-segment. And we know that the rule about the mid-segment's length. The length of the mid-segment is 1/2 of the sum of the bases. So the mid-segment. The mid-segment. The length of that mid-segment is equal to 1/2 of base 1 plus base 2. So if you are one of the formula people that you need a formula to remember, there's the formula for the mid-segment's length. So as I look at number 9, the mid-segment's length is x. It is equal to 1/2 of the sum of the 2 bases, 10 plus 18. So x equals 1/2 of 28. Half of 28 is 14. The length of the midsegment is half of the sum of the bases. Turning my attention to number 10. Number 10 is another trapezoid. The top is parallel to the bottom. M is a midpoint. N is also a midpoint. So the segment that is 20 units long is a midsegment. And I know that the midsegment, 20, is equal to 1/2 of the sum of the bases, x plus 17. Now at this point you have a couple of options to solve. I can distribute the 1/2 if I wanted to. But because I don't know half of 17 real well, with it being a decimal, I'm going to get rid of the half another way. I'll multiply the left and right by 2. When I multiply the left by 2, it becomes 40. And when I multiply the right by 2, I just get x plus 17. I'll subtract 17 on both sides. $23 will be my x value. X is equal to 23. Looking at 11, 12, and 13, those questions have to deal with kites. We did not cover kites in this unit, so we will just move right along. Moving down to number 14. Number 14 says, in rhombus JKLM. So I know this. I know that I have a rhombus. And there are certain traits of rhombi that I should know. Number 1 trait, all 4 sides are the same. So the top, bottom, the left, the right, all the same length. Second trait I should know is that the diagonals are perpendicular. So these are all right angles. Some of the other things that I'm told that the measure of angle LMO is 30. So LMO is 30 degrees. I'm told that the distance from O to J is 18. And M to K, I know this big distance here, this long diagonal is 36 radical 3. Well, since diagonals bisect one another, if the whole diagonal is 36 radical 3, then half of the diagonal is just half of 36 radical 3. Half of 36 radical 3 is 18 radical 3. So I'll have 18 radical 3, and I'll have 18 radical 3. If OJ is 18, then JL is also 18. Some of the nice properties of parallelograms that I know. The other special trait about parallelograms are that the diagonals are not only 90 degrees, but they also bisect the angles. So that means that angle LMO and angle JMO are congruent, as are the top two. These are all 30 degrees. Those are all 30 degrees. Well, let's start answering some of these questions. Question A says, what is the measure of angle JOK? So from J to O to K. If I look at JOK, it's down here in the middle. And we said that one of the properties of all rhombi is that the diagonals are perpendicular. So JOK is 90 degrees. It is perpendicular. The measure of angle LKO up here in the top right, well, we found those, all of 4 of those angles, top right and bottom left. The pair in the top right, the pair in the bottom left, they are all 30 degrees. 30 degrees. So to find MJO right up in this little corner up here, to find this angle right up there, I need to take a look at my triangle. The triangle MJO. MJO triangle is a 30 plus 90 plus something has to equal 180. 90 and 30 is 120. So that means this angle is 180 minus 20, or 60 degrees. So those are 30, 60, 90 triangles, which is great. 30, 60, 90 triangles, we've learned a lot about those. So 60, 60, 60, 60. So I think I know about everything that they want us to know. Part D asks us for LJ, the distance from L to J, for the second diagonal moving from top to bottom. That diagonal, that is made up of two pieces that are both 18. So 18 plus 18 is 36. That is 36 units. And in order to find LK, I can think back to my special right triangle. My special right triangle has a short side. The side across from 30 degrees is 18. And my special right triangle says that the hypotenuse is always twice the short leg. So the hypotenuse of a 30, 60, 90 is equal to 2 times the short leg. Well, the hypotenuse then, LK, is equal to 2 times the short leg, which is 18, or 36 units. So it is also 36 units. Moving on to question 15. As I said in class, question 15, the A, B, C, D pairs or options are not correct. There is not a correct answer in here. So what I'm going to do is I'm going to take you through the way to find either one of these two. So the first thing I'm going to do is I'm going to try to graph all 3 points. Point A is at 1, 1. Point B is at 15, 3, way out here somewhere. It's way out there somewhere. And point C is at 7, negative 5. So I have 2 places where D could possibly exist. So I'm just going to kind of look at this and say D could be in 2 places. D could be way out here. Way out here to the right. Somewhere way out there. Past B, way out there to the right. Or D could be somewhere right up in here. D could be somewhere up in there. Either way, I can make a parallelogram. So that's kind of what my thinking is going on here. So I need to look at this as 2 different scenarios. So I'm going to do scenario 1, where D is way out to the right. And I'm going to say, I want AB, this distance, that side, and CD, way out there to the right. Those 2 things, I want those 2 things to be parallel. So I am going to count. How do I get from A to B? Well, A is located at 1, 1, and B is located at 15, 3. So that means I'm going to go up 2, rise 2, and I'm going to run way out there. I'm going to run 14. I'm going to rise 2 and I'm going to run 14. Well, if I started at C and I did a rise 2 and a run of 14, where would that point be? Well, the C coordinate, let's look at it. C coordinate, right here. If I rise 2, it's at negative 5. If I rise that up 2, I would be at negative 3. And if I'm located at 7 on the x-axis, and I said you had to go to the right 14 more. 14 more than 7 is 21. So one option for D is 21, negative 3, which is really close to the answer in A. 21, negative 3. Okay, let's pretend, let's get rid of all this green. And let's say that I know that D could be somewhere up in here. I don't know where, somewhere up in there. And I know that if I did BC and AD, if those two were parallel, I would have a parallelogram. So I'm going to find, how would I get from C to B? Same scenario. I would rise, and I would run. Well, how far would I go? Well, C is at negative 5. Depth, way down here at negative 5. And B is all the way up here at positive 3. So from negative 5 up to positive 3, I would have to go up 8. And then my run, C is at 7. C is at 7. So I would have to run from 7 out to 15. So I would have to run 8. So rise 8, run 8. Well, now let's go to look at A. From A, I need to go up 8, and I need to go right 8. Well, if A is at 1, 1, if I rise 8 and run 8, let's run 8 first. 1 plus 8 is 9. Rise 8. I start at 1 and rise 8 more. 1 plus 8 is also 9. So D could be located in two places. It could be at 21, negative 3, or it could be at 9, 9. So you'll notice that none of them are exactly right. A and B are both really close. We've got some signs a little messed up in there. But the two places in which you could put D in order to make a parallelogram are at 21, negative 3 and 9, 9. For those of you watching this video, there is not one of these questions on the quiz or on the final test. The last two, looking at 16 and 17. Given the following vertices, we graph the quadrilateral, classify the quadrilateral, list all quadrilaterals that apply, show your supporting work. All right, so in part A, I'm going to start by first plotting these points. Let's graph. Q is at negative 4, negative 1. U is at negative 2, negative 5. A is at 4, negative 2. And D is at 2, 2. Here is my quadrilateral. So I need to check two things. I'm going to try to find the slope and the distance of all four segments. The slope and the distance. So my four segments are QU, UA, AD, and DQ. And I'm going to find the slopes and the distances. So let's start with slope. All right, the slope. To find slope, it's just rise over run. So from Q to U, rise, going down, 1, 2, 3, 4. So rise, -4, run 2. I could rewrite this as a simplified fraction, -2/1. From U to A, let's do rise over run. From U to A, I rise, 1, 2, 3. I run, 1, 2, 3, 4, 5, 6. 3/6 reduces to 1/2. From A to D, rise, 1, 2, 3, 4. Run left, 1, 2. Reduces to -2/1. From D to Q, run or rise, down, 1, 2, 3, -3. Run left, -1, 2, 3, 4, 5, 6. Reduce to 1/2. So checking to see are opposite sides parallel. QU and DA have the same slopes. They are parallel. UA and DQ have the same slopes. They are parallel. So opposite sides are parallel. This is a parallelogram. It is a parallelogram. Now, before I can check for other types of parallelograms, the first one I always like to check is I like to check to see, is it a rectangle? Do I have a 90-degree angle? And I can find a 90-degree angle by looking at two adjacent sides, like QU and UA. And if their slopes are opposite reciprocals, then I know that those two things are perpendicular. And -2/1 and +1/2 are absolutely that. They are opposite reciprocals. So that means I have a 90-degree angle in each one of these because of the pairs of opposite reciprocals, which means that, yes, this is a parallelogram, but it's also a rectangle. All right, my next option. Check to see, is it a rhombus? If it is a rhombus, all four sides have to be the same. And since it's a rectangle, if it's a rhombus, it's also a square. So how do I find the distance? I will use the square root of a squared plus b squared. So the square root of a squared plus b squared. A squared is from Q to U. So I did down and over. I went down 4 squared. Plus, my right, I went over 2, so 2 squared. 4 squared is 16, plus 4 is radical 20. And I'll just leave it as radical 20. I'm fine with that. I could look at the decimal if I wanted to, because really the only thing I care about is UA the same distance. So the square root from U to A, I went up 3 and over 6. So 3 squared plus 6 squared. 3 squared is 9, 6 squared is 16, and 9 plus 16 is 25. The square root of 25, we know, is 5. But it does not equal the square root of 20. So QU and UA are not the same. So therefore, it is not a rhombus. And if it's not a rhombus, then obviously it is not a rectangle. So this figure is both a parallelogram and a rectangle, and that is it. Could I find the distance of AD and DQ? Absolutely. You would find that AD is radical 20. You would find that radical 25 is the distance of DQ. So you have opposite sides are congruent, but they are not all congruent. You're still stuck at parallelogram and rectangle. Moving on to B. Let's plot the points first. M, A, T, H. We're just looking at these points. It's pretty easy to tell that this is not a parallelogram. But I'm going to do the same thing as before. I am going to connect the dots. M to A to T, T to H, and H to M. And I am going to find the segments, slopes, and distance. So the segments are MA, AT, TH, HA, or I'm sorry, HM. I'm going to find the slope, and I'm going to find the distance. So the slope from M to A, rise and run. I rise 1, I run 4. From A to T, I rise, I go down 3, and I run 4. From T to H, I go down 4, and I run 0. This is actually undefined. It's actually undefined. And H to M, I go up 6 and left 8. That reduces to -3/4. So I look for first are opposite sides parallel. So are MA and TH parallel? No. One has a slope of 1/4 and one has an undefined slope. Then I look at AT and HM and I see that they both have the same slope of -3/4. That means they are parallel. So I have one pair of parallel sides, which means this is a trapezoid. I have a trapezoid. Now I'm going to check to see, is the trapezoid isosceles? So I know this, AT and MH are not going to be the same length. I can see that, that's very easy. I am only going to check the length of MA and the length of TH. So the length of TH is easy, I can count. That is 4 units. And this distance down here is 4. Now I'm going to find the distance of MA, the square root. I went up 1 and over 4, so 1 squared plus 4 squared. Well, 1 squared is 1, 4 squared is 16, and the square root of 17 is not 4. So it is not isosceles, but it is a trapezoid. That concludes the practice test. I hope you got something out of this, and as always, if there's something that you would like to see changed in the future, or something that you think I can correct or improve upon, please send me an email or stop me after class and let me know. Thank you.